Hello, geometry students. So today we are going to begin our next unit, which is on right triangles. Notice I wrote right triangles in my notebook. So if I'm referring back to the table of contents, okay, right triangles, I'm starting on page 78. And if you haven't been keeping up with your table of contents, here's your chance to do so. You can always pause the video and fill it out if you feel the need to. So again, this next lesson is on right triangles. We're going to cover Pythagorean triples, special right triangles, sine, cosine, and tangent, along with some word problems. So it's not going to be an extremely long unit, okay? So for the first part of today's lesson, we are going to review a little bit. We have covered right triangles a little bit already, and that was with, remember, the Pythagorean theorem. Okay, remember the Pythagorean theorem works for a right triangle. And remember, it says that if A and B are legs and C is the hypotenuse of your right triangle, that A squared plus B squared equals C squared. So if we just practice a couple examples. Okay, so let's pretend I have a right triangle like this, and that this is 6, and this is 10, and we'll call this X. So according to Pythagorean theorem, again, my C would be the 10. The A and the B would be the 6 and the X in either order. So I would have X squared plus 6 squared equals 10 squared. So X squared is X squared, obviously. 6 squared is 36, and 10 squared is 100. So if I'm going to solve for X, I'm going to subtract 36 from both sides of the equation. So I'm going to have X squared equals, so 100 minus 36 is 64. And then to find X, I'm going to take the square root of both sides. So X is going to be 8. So my missing side here is 8. Okay, let's do another one. So let's pretend this is my right triangle. And let's see here. Let's pretend this is the square root of 3. This is 1, and we'll call this X in this particular problem. So again, Pythagorean theorem would tell me that A squared plus B squared equals C squared. In this particular problem, my X is my C. So I'm going to have 1 squared plus the square root of 3 squared equals X squared. Well, 1 squared is still 1. Remember, when you square a square root, it undoes itself. Or you can actually square it, like 3 squared is 9. The square root of 9 is 3, or just think, again, the square root undoes itself. So 1 plus 3 equals X squared. So if I'm going to continue to solve for X, I'm going to add 1 plus 3, which is 4. So 4 equals X squared. To find X, we're going to take the square root of both sides. So X is going to be 2. So again, in this particular problem, my hypotenuse has a length of 2. Let's do one more, just for review. Okay, so this time, let's see here. I'm trying to make up some numbers. Let's do, I don't know, let's do 4. And let's do a 6, and we'll call X the hypotenuse again. So again, according to Pythagorean theorem, A squared plus B squared equals C squared. The C is always the side across from your right angle, and that's your hypotenuse. So in this problem, we would have 4 squared plus 6 squared equals X squared. 4 squared is 16. 6 squared is 36. Okay, so if I add it together, 16 plus 36 is what, 52? So to find X, we're going to take the square root of both sides. 52 is not a perfect square. So if it's not a perfect square, we want to give an exact answer. You got to stop and think, is 52 divisible by a perfect square? Okay, I'm going to say yes, it is. It is divisible by 4. 52 is 4 times 13. So the square root of 4 is going to be 2. So my answer for x is going to be 2 root 13. So again, if it's not a perfect square, you want to simplify it if possible. So for your first assignment today, you have a worksheet. The title is Pythagorean Review, because we're reviewing Pythagorean Theorem. So you're going to find the missing side of each triangle. You're going to write it as a radical if needed. Do not round as decimals. Okay, so you've got 10 problems on this. Okay, that's the first part of your assignment. So if you want to do that first and pause the video, that's fine. Otherwise, we're going to continue. So the new part of today's lesson is the notes that you should have gotten. So if you think about it, what you're going to do with your stapled paper here is you're going to tear them apart, and then you're going to trim them down to fit in your notebook, just like I've done here. So I've got my 2 pages, again, trimmed down. So the focus for the other part of today's lesson is on Pythagorean triples. Just highlighting that so it sticks out. So again, it's on Pythagorean triples. So I've got the definition box here to fill out. So a Pythagorean triple consists of any 3 numbers that satisfy the equation. Satisfy the equation a squared plus b squared equals c squared. Any 3 numbers that satisfy it form a Pythagorean triple. And normally we think of these as integers. It's more specifically, I should say, whole numbers. Okay, so again, they are numbers that form a Pythagorean triple. Those are ones that fit the Pythagorean theorem. So there are 5 that you have listed on your notebook here that I expect you to know. These are common ones. Okay, so these are, again, our common Pythagorean triples. So for example, we have 3, 4, 5. Okay, think about it. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. The square root of 25 is 5. 5, 12, 13 works as well. 7, 24, 25. 8, 15, 17. And 9, 40, and 41. And any multiple of these Pythagorean triples are true as well. For example, if I have 3, 4, 5, and I double it, I would have 6, 8, and 10. That's another triple. If I would triple it, I would have 9, 12, 15. Again, another Pythagorean triple. If I multiply it by 5, I would have 15, 20, 25. Again, another Pythagorean triple. Again, a multiple of any of these work. Now, there are more than these that exist. These are the ones we're going to focus on. So we're not going to be using Pythagorean theorem in the second part of today's lesson. We're going to focus on using one of these 5 triples. So if I'm looking for the missing sides, looking at my examples. So this first one, we have a 3 and a 5, and I'm looking for this side. Well, if I'm looking at my triples here, there's this triple that has a 3 and a 5 in it, so my missing side would be 4. So again, 3, 4, 5. If I look at this one, we have a 5 and a 12. Okay, do I have a triple with a 5 and a 12 in it? Yes, I do. 5, 12. So that means my hypotenuse is 13. And maybe I should specify. The third column here, this is your hypotenuse. The hypotenuse is always the longest side. Okay, so if I continue with my other examples, I have a 7, a 24, and I'm missing the hypotenuse. Well, again, look at one of your triples. There's one that has a 7, 24 in it. The third number is 25. So again, the hypotenuse is going to be 25. In this one, we have a 15 and a 17. So I'm looking at my triples. Do I find one with a 15 and a 17 in it? Right here, 8, 15, 17. So that means my missing side here is 8. And then the last one on this page, if I have a 9, a 40, and a blank. So again, I'm looking for a triple. Does one have a 9 and a 40 in it? 9, 40, yep, 41. So that means my hypotenuse is 41. Now, I could use Pythagorean theorem if I wanted to. Okay, but this is meant to be quicker. Okay, if you can recognize these make problems, other types of problems go quicker as well. Okay, so let's look at my other side for my examples. And I apologize, it kind of had light printing here, so I'm just going to go over them. So this one's 50, this is 48, and the one on the right we have a 28 and a 35. The one at the bottom here we have 0.7 and 2.4. And then the very last one I have a 10 and an 8. So again, what we're going to do is find the missing side. So if I look back to that first problem again, so we have a 50 and a 48 for two sides. So if I look back at that table, none of them have a 50 or a 48 in them. I don't see anything with a 50 or a 48. So now, if it's not that, I got to stop and think. Okay, are 50 and 48, do they have a common factor? Are they both divisible by the same number? Well, hopefully you're thinking yes. 50 and 48 are both divisible by 2. They're even numbers. So 50 divided by 2 is 25, and 48 divided by 2 is 24. So now if I look at my table, do I have a triple that has a 24 and a 25 in it? Yes, I do. This one right here, 7, 24, 25. So the one I'm looking at is a multiple of one of my triples. So again, this side here would be 7. Now, is it really 7? No, because this side here is not really 24. It's 24 times 2, which is 48. The hypotenuse would be 25 times 2, which is 50. So this side DE that I'm trying to find, I got to double it because it's a double of your 7, 24, 25 triple. So 7 times 2 is 14. So my missing side really isn't 7, it's 14 because I would have to double it. Okay, so now if I look at the one on the right, we have a 28 and a 35 here. So again, if I look at my table, I don't see any with a 28 or a 35. I don't see any of those numbers there. There's a 25, or that's not even a 20. I don't even want a 25. I want a 28 and a 35. It's not listed there. So now I'm going to go back to my picture. Do 35 and 28 have a common factor? Are they both divisible by the same number? Hopefully you're thinking, hey, yeah, they're both divisible by 7. So 35 divided by 7 is 5. 28 divided by 7 is 4. Do we have a triple with a 4 and a 5 in it? If we stop and check, yeah, we do. We have 3, 4, 5. So that means this missing side, MN, is a multiple of 3. So to figure out what the actual length is, if you think about it, 4 times 7 was 28. 5 times 7 was 35. So to find this missing side, MN here, we would take 3 times 7, which is 21. So again, these problems that we're looking at are either going to be an exact Pythagorean triple or a multiple of them today. Okay, on this next one, we have 0.7 and 2.4. I don't have any with decimals on them, right? But if I look at my triples, so 0.7 and 2.4, well, this one's got a 7 in it, and 2.4 is kind of like 24. So if you think about it, this is a multiple of the 7, 24, and then the third number is 25. What I'm really doing on this one is dividing it by 10. So this hypotenuse would be 2.5. So it works for division as well for multiplication. Okay, the last one. We have an 8 and a 10. Again, if I look at my table, I don't see, there's one with an 8, but that one doesn't have a 10 in it. So I gotta stop and think, what do I do? So if I think about it, 8 and 10 do have a common factor. 8 and 10 are both divisible by 2. 10 divided by 2 is 5. 8 divided by 2 is 4. I do remember a triple with a 5 and a 4 in it. Again, remember, it's the 3, 4, 5 triple. So that means this side FE is a multiple of 3. So again, to figure out what that side is, you got to stop and think. Okay, to get from 4 to 8, I multiplied by 2. To get from 5 to 10, I multiplied by 2. So to get from 3 to this side here, I'm going to multiply by 2. And 3 times 2 is 6. So again, we reviewed Pythagorean theorem in this video, as well as focused on recognizing Pythagorean triples. So for your other assignment today, you again have another worksheet. Okay, this worksheet is not meant for you to do Pythagorean theorem. It's meant for you to focus on Pythagorean, you got it, Pythagorean triples. It says it right here. So every problem on this worksheet, and there is a front and a back as well, but every problem on this worksheet is either one of your Pythagorean triples exactly, or it's a multiple of your Pythagorean triples. Okay, so for today, you need to finish both worksheets. The first one you're going to do with Pythagorean theorem. The second one, both sides, you're going to do with Pythagorean triples. Okay, good luck. And if you have any questions, please let me know.